Good morning, student. VN Karnar, PGT Physics from Jawahar Navodaya Vidyalaya, Shega. So today we'll discuss the triangle law of vector addition. Vector addition. So first of all, we'll see this law. That means how the vectors can be added here. That is addition or composition of vector. And you can see the composition of vectors. We have to see the triangle law of vector addition, parallelogram law of vector addition, and polygon law of vector addition. So out of this one, let's discuss about the triangle law of vector addition. What is the triangle law of vector addition? Suppose you are having the two vectors, this A and B. Suppose vector A is here and another vector B is here. Okay. So another vector B is here. Then suppose you want to add these two vectors, that is vector A and vector B. If you wish to add these two, then we have to draw a vector OP equal and parallel to vector A. That means what I will do here, I will draw vector OP equal and parallel to this A. Is OP vector equal to parallel to vector A, you can say. Okay. And has a head P of OP. From this head OP, draw vector PQ parallel to B, equal and parallel to vector B. That means suppose you are having this vector B here, then you can draw, you have to just drag this one this side. One thing you have to keep it in mind, for this vector B, when you are dragging here, at that time you don't have to change the direction. Direction will not be changed. Direction should not change. And also magnitude. Magnitude should not change. So you just take this vector B, or you can draw a vector PQ. Suppose vector PQ is having equal in magnitude parallel to B here. Then the resultant vector is given by OQ, which joins the tail of A. This is the vector A, tail of vector A, and the head of vector B. So like this. This is the closing side, you can say. This is your resultant R. And this resultant is nothing but here vector A plus vector B. Okay. So this is nothing but your simple triangle law of vector addition. See, vector A is given. So what is the magnitude? And you can say here the direction. Same I have dragged here vector OP. Similarly, vector B having magnitude and direction, same I have dragged here, which is parallel to this PQ, you can say here. And the closing side taken in reverse order. See here, the arrowhead here of OP is this side, then PQ is this side. That means you are going from this side. OP, OQ, then should not draw like this. Closing side should not be draw like this. That means this arrow should not be here, but the arrow should be taken in reverse order. Arrow should be, closing side of this triangle should be taken in reverse order. So that is nothing but your resultant vector. So R is equal to A plus B. Now you will proceed for the analytical treatment. We will proceed for analytical treatment of triangle law of vector addition. That means if you want to find the magnitude of the resultant vector R and the direction, then that time you have to proceed for this analytical treatment of the triangle law of vector addition. Vector addition. See here, analytical treatment. Once again, I am using the same figure. So here the vector A represented by this OP, vector A, and vector B is by PQ. PQ. So the closing side, I can take the closing side as this one. Closing side, this is nothing but your resultant vector. That is vector A plus vector. Okay. So here this is nothing but your vector B. Now see, this is resultant vector which makes an angle here beta with the vector A. Okay. Now I will just extend this OP and draw perpendicular from this Q to this extended OP. Here the angle is theta. And this perpendicular is point. I'll give the name N. Now here, maximum students, they will understand about this beta. This is nothing but the angle by the resultant vector, that is OQ, with the vector A, or you can say with OP. Now how this theta is, you will get here. See, vector A you are having here, having the same magnitude and direction. Vector B, suppose initially if you are having vector B here, then suppose I will drag this one to this particular point. This point will be shifted to this point like this. Is vector B. Then this angle is theta. And if you drag again here, or I will draw a parallel vector to this vector B from this one here. And when it is extended, then this angle and this angle will be same. Ultimately, this angle is nothing but the angle between the vector A and B. I think you have understood now. Beta is different. Beta is here like this. Beta is this one, which is the angle between the resultant vector and the vector A. But theta is the angle between this vector A and B. Now we have to find the magnitude of the resultant vector, or you can say simply R, and also direction of the resultant vector. Okay, so we'll proceed for finding this 2 point now. So I hope you understood the triangle law of vector addition, and now we'll discuss about the analytical treatment. So description of the figure is like this. Already we have told the two vectors A and B are represented both in magnitude and direction by OP and OQ. OP and PQ here. A triangle OPQ taken in same order. Taken in same order means like this one. Taken in same order. Then according to the triangle law of vector addition, the resultant vector R is given by closing side OQ taken in a reverse order. These two are going in this direction, so this will be in the reverse direction. Okay, as shown in this particular diagram. So the first thing is about magnitude of resultant R. Magnitude of the resultant R. We have to find. Now what I have made in this figure, I have drawn perpendicular from this point Q to the you can say OP produced to the up to the point N. Then from this angle QPN, this angle is theta. OP is equal to, in terms of magnitude, OP is A, then PQ is B, and OQ is equal to R. in terms of magnitude. So here the angle theta, then OP is equal to A, magnitude of vector A, PQ is nothing but magnitude of vector B, and OQ is nothing but magnitude of the resultant vector R. Therefore, A, B, C are respectively the magnitude of the three vectors. Okay. Then from this right angle triangle, I can write that is QPN from triangle. No doubt it's the right angle triangle. That is right angle triangle Q and P. What I will get here? Sine theta is equal to Qn by PQ. So I can write here Qn is equal to PQ sine theta. What is PQ? See, B. So I can write Qn is equal to B sine theta. I'm not having the value of this Qn. Qn I am not having. Okay. So Qn is equal to B sine theta. Again, go for the cos theta. In the same right angle triangle, cos theta is equal to adjacent side divided by hypotenuse, that is Pn by PQ. So I can write here Pn is equal to PQ cos theta. Again, this Pn I am not having. So PQ is equal to, what is the value of Pn? What is the value of PQ here? The PQ is nothing but here B. So B cos theta. So I got these two equations, or the values of Qn and PQ, from this right angle triangle. Now, if I want to find out the value of, you can say OQ, then simply I will use OQN. This total is right angle triangle. So I can write OQ square is equal to ON square plus QN square. Okay, ON square plus QN square. So I can write this ON as OP plus PN. OP plus PN whole square plus QN square, that is OQ square. So I will put the value of this OP PN from this one. OP is A, and this PN from this one, PN is equal to, sorry, here not PQ, here should be PN. So PN is equal to B cos theta, and QN is equal to, you can say, B sin theta. So putting this value in this equation, and this OP already having A, so OQ square is equal to A plus PN is what? B cos theta. B cos theta square plus, what is Qn? B sin theta. So B sin theta square. So OQ square is equal to, just A plus the bracket square I can write. So A square plus twice AB cos theta plus B square cos square theta plus here also B square sin square theta. B square sin square theta. So again I will use here the identity sin square theta plus cos square theta is equal to 1, because here also B square you are having, and here also B square you are having. Okay. So finally we can say we get this equation as OQ square is equal to A square plus B square, because sin square theta plus cos square theta is equal to 1, plus twice AB cos theta. What is OQ? OQ is nothing but R. So I can write R square is equal to A square plus B square plus twice AB cos theta, or R is equal to square root of A square plus B square plus twice AB cos theta. This is the magnitude of the resultant vector R. This is the magnitude of resultant vector R. I think all of you have understood this one. Once again, see here. So in this triangle of vector addition, I have taken vector A and vector B. Then these two are making an angle theta with each other. Then by using the vector law of vector addition, I got the resultant vector, vector A plus vector B, and the resultant vector makes an angle beta with the vector A. So by using this triangle, right angle triangle concept here, by making some construction here, so I have calculated the value of the resultant vector r is equal to a square plus b square plus twice ab cos theta, or in word you can say that resultant vector r is equal to square root of magnitude of the square of the vector a plus magnitude square of the magnitude of vector b plus 2 times the magnitude of vector a and b into cos of the angle theta, or theta, where the theta is the angle between a and b. So this is the nothing but your magnitude of resultant vector. This equation gives you magnitude of resultant vector r. Okay, so this formula is very helpful for you in so many cases. So once again you try to revise these things so that this formula will be remember at any time whenever it is needed. Now we'll go for the direction. We have find out the magnitude here. Now we'll proceed for the direction. How to find the direction here? So to find out the direction, that means we have to find beta here. Okay. So in case of finding the direction of the resultant vector, that is nothing but your r or OQ, vector OQ. Next point is here, direction of resultant vector r. So the resultant vector makes an angle beta with the direction of vector A. Then from the triangle ONQ, from this triangle ONQ, I'll get tan beta is equal to QN divided by ON. What is QN here? So I can write QN, just we have calculated that QN is equal to, see here, QN is equal to PQ sin theta. What is PQ here? B. So I can write here QN is equal to B sin theta. So B sin theta divided by, what is ON? ON is nothing but OP plus PN. That is OP plus PN. So B sin theta divided by OP is nothing but magnitude of vector A plus, what is Pn? Pn is nothing but B cos theta. Just now we have proved. From this one, you can have the value of this tan beta, or beta is equal to tan inverse of B sin theta upon A plus B cos theta. You can also calculate. So by using this relation, you will get the direction of the resultant R, or resultant vector R. So I hope in this particular topic, we have found the magnitude as well as direction. Now we'll proceed for the analytical treatment for the parallelogram law of vector addition, which is based on the same method. Whatever we have proceeded here through this, all this concept, or the values, or the formula, or the, you can say, the sine and cos functions we have used here, and whatever the value we get, the magnitude r of the resultant vector, same you will get in that case also. But let me tell you, or some things related with that particular parallelogram of vector addition. So first we'll see about second topic, we'll see, you can say, that is parallelogram law of vector addition. Vector addition. Oh, what is parallelogram law of vector addition? Suppose now you are having this vector E and this another vector B. Okay, now you have to, from that means, from, if you want to wish, or if you want to add these two vectors A and B, vector A and B. Then from the common point O, suppose I will take here point O, draw OP equal and parallel to A. I will draw OP equal and parallel to A. So whatever the magnitude and direction of A, I have drawn here O. And vector, you can say this equal vector for this vector B, you can say. Now we'll proceed for the vector B. So this OQ, if I will draw here OQ, that means like this one. OQ, nothing but your vector B, which is also equal and parallel to this OQ is vector OQ is equal and parallel to this vector B. Okay, then we'll complete the parallelogram. How will complete the parallelogram? Just by doing this process. Okay, I have completed the parallelogram now. So after completing this parallelogram, so according to the law of vector addition, the diagonal OS, this one, OS gives the resultant vector R. So what I have done here, in case of triangle law of vector addition, you have taken here vector A, same as that of this vector. Then you have dragged this vector B on the head of this one without changing the direction and magnitude. You can say here vector B. And then you have closed this triangle or closed this side by this resultant vector R. Now what I have done here, I have taken vector A, that is OP is a vector which is equal and parallel to this vector A. Then OQ is equal and parallel vector to B. And then I have completed the parallelogram by these two sides, that is QS and SP, closing this two one. And I have drawn the diagonal OS, vector OS, which is nothing but your resultant vector R. So I can write this resultant vector just like this one. See, this B, vector B or vector, you can say OQ is nothing but your this side PS. So this is also, you can see a B. And similarly, vector OQ is nothing but you can decide OS. So I can write resultant vector R is equal to vector A plus vector B by using the same concept here. Okay, I think you understood now this particular parallelogram law of vector addition here. So now I want to find the analytical treatment. So about this analytical treatment of parallelogram law of vector addition. So I will proceed here. Analytical treatment. Of the parallelogram law of vector addition. So let me draw first the figure. So this is OP vector is having equal and parallel to vector A. Then you can say OQ which is equal and parallel to vector B. Then just I will complete this one. I'll complete this parallelogram. And the resultant, or you can say the diagonal, which is resultant R, which is equal to vector A plus vector B. Ultimately, I am using here the most of the part of the triangle law of vector addition. Now, if you want to find out the magnitude and direction of the resultant vector R, again, I will use the same concept of the triangle law of vector addition. That means here I will use this angle beta. I will extend this OP, and from this point S, I will draw a perpendicular so that this point is N, and this angle is theta. Already I explained you about this angle. This is nothing but the theta is the angle between this vector. You can say this angle, the angle between these two vectors, vector A and vector B. So for the magnitude of the resultant R, so first one, magnitude of resultant R, I will use the same concept. I will apply a sine and cos for this triangle. So I can write sine theta is equal to Sn upon Ts. So Sn upon what is Ps? Ps is nothing but the magnitude of vector B, that is B. So Sn is equal to B sine theta. First equation. Second one, I can write cos theta is equal to what is cos theta? Pn upon Ps. Again, Ps is nothing but here you can say B. So Pn upon the magnitude of vector B. So Pn is equal to B cos theta. Now by using I use the Pythagoras theorem for this triangle. For this triangle OSN, in this triangle, OS square is equal to ON square plus SN square. What is ON? ON is nothing but OP plus PS. So OS square is equal to OP plus PN square plus SN square. Okay. Now I will put the respective value. So OS is nothing but resultant vector R. So R square in terms of magnitude, R square is equal to what is OP? OP is nothing but the magnitude of vector A plus PN. See here, PN is equal to B cos theta. So B cos theta square plus SN. SN is nothing but B sin theta. So B sin theta square. So R square is equal to A square plus twice AB cos theta plus B square cos square theta plus again the square of this term B square sin square theta. So R square is equal to, see here, I will use the identity sin square theta plus cos square theta is equal to 1 by taking this B square as a common one. And again here A square plus B square, I will take that B square here, and the remaining term is as it is plus twice AB cos theta. Or I can write R is equal to square root of A square plus B square plus twice AB cos theta. So this is the magnitude of the resultant vector R. Again, for the, you can say the direction of the resultant vector. So again, you use tan beta is equal to, for this right angle triangle, ONS. Then I can write tan beta is equal to SN divided by ON. What is SN? That is B sin theta. What is ON? ON is nothing but OP plus PN. OP is nothing but your A, and PN is nothing but your B cos theta. So I can write here tan beta is equal to B sin theta upon A plus B cos theta. So dear student, this equation, suppose this equation is number 2 and this equation number 3, these equations are very important. This gives the direction of the resultant vector R, and this equation gives the the magnitude of the resultant vector R, and this equation gives the direction of the resultant vector R. Or you can also you can write here that is beta is equal to tan inverse of B sin theta upon A plus B cos theta. So I think this part from this, the magnitude and as well as the direction of the resultant vector, same as that of triangle law of vector addition. So I hope you will not find any difficulty for this the analytical method for the vector addition for these two laws, that is triangle law of vector addition and parallelogram law of vector addition. So these two law of vector additions are very important, and especially if you have to remember these two formulae. Okay, you remember one thing, you keep it in mind whenever you are proving any formula here. Suppose we have proved the resultant vector, but what vectors you have used here? You have used vector A and vector B. These two vectors you have used here. Suppose instead of vector A and vector B, if you will use some vector, suppose vector X, okay, and vector Y, if you use these two vector, then the respective changes will take place in this formula. So at that time, you should not get confused. So always remember any of the formula in words. So in words, how will you remember this formula? The resultant vector, magnitude of the resultant vector is equal to square root of the square of the magnitude of first vector plus square of the magnitude of second vector plus 2 times the uh, product of magnitude of both the vectors and the cosine of the angle between them. So this is the relation for how you will remember the formula here. Similarly, for tan beta also you can remember. So my only intention is that whenever you are using the different vectors, then you should be able to write this formula in that particular form only. Okay. For example, here suppose x and y you will take here, then this formula will change as r is equal to square root of x square plus y square plus twice xy into cos theta, like this one. So it is very easy to remember also, and similarly for this direction of the you can say resultant vector r by given this particular formula. I hope all of you understood these two laws of vector addition and try to remember this formula for the calculation purposes.